Welcome back, friends. So in the previous class we have started with the duality property. So still I am going with the duality property only. So let's see, find Fourier transform for sampling square 80. Sampling square 80. It is also not this simple. So just we have to think in terms of duality. So for this one, duality is nothing but sampling square a omega. So to get sampling square a omega, what should be the time domain? What should be the time domain? The time domain is nothing but a triangular function. Okay, triangular function, I can understand. What is this A indicates? It is nothing but width by 4. If it is width by 4, what is the width actually? 4a. If width is 4a, if it is symmetrically located, it has to be minus 2a and plus 2a. Okay. Next, what is this coefficient 1 indicates? Area under this triangle. So if it is area under this triangle, half base into height. So half base, that is nothing but 2a. Then what should be height? So that it is going to be 1 by 2a. 1 by 2a. So this is the function what we got. If it is in the time domain, it is in the frequency domain, omega domain. Now if I apply the duality property, sampling square at, if I replace omega with t, then here we have to multiply this function with 2 pi and we have to fold the signal. If I fold the signal, will it make any difference? No, not at all. So I can get same signal between minus 2a and plus 2a. This is frequency domain omega. And here 2 pi has to be multiplied with 1 by 2a, which is nothing but pi by a. So I hope you understood. So for sampling square 80, again we are going to get triangular function with minus 2a to 2a pi by a. Clear? Take it. Integral minus infinity to infinity sampling 80 dt. Sampling 80 dt. I want to solve this integral. So I can treat this sampling 80 as x of t. So integral minus infinity to infinity x of t dt, from the central ordinate property, this is going to be equal to x of 0, capital X of 0. So what is that? Let's see. First, for x of t, that is sampling 80. Sampling 80. What is x of omega? So just now we have seen it is a rectangular pulse. In the previous class we have seen this. 0 minus a plus a, and it is pi by a. Pi by a. So what is x of 0? At 0, what is the value here? So this is also pi by a. So which is equal to pi by a. Pi by a. In the similar way, suppose if I want to find out integral minus infinity to infinity sampling a omega d omega. Sampling a omega d omega. Now if I take this value as x of omega, so that is nothing but integral minus infinity to infinity x of omega d omega. From the central ordinate property, this is equal to 2 pi x of 0. 2 pi x of 0. So to get sampling a omega, what is x of t? Sampling a omega. So to get this x of omega, what should be the time domain x of t? That is again a rectangular pulse whose width is equal to 2a. So it is minus a to a. and height has to be 1 by 2a, so that its area becomes 1 by 2a. So this is what x of t. So at 0, what is its value? 1 by 2a. So finally this is going to be 2 pi 1 by 2a. 2 get cancelled. Finally this is also pi by a. If you observe carefully, sampling at dt or sampling a omega d omega is going to result the same, which is nothing but pi by a. Next, if I take integral minus infinity to infinity sampling square at dt, sampling square at dt. So here also I can take this value as x of t. Again, from the central ordinate property, this will give you x of 0. So to get sampling square at, what is its Fourier transform? X of omega. We have seen it is nothing but a triangular pulse with respect to omega minus 2a plus 2a pi by a. So at 0, what is its value? Which is nothing but pi by a. Next, another integral minus infinity to infinity sampling square a omega d omega. So from central ordinate properties, let's call it as x of omega. If I call it as x of omega, then from central ordinate property, this is nothing but 2 pi small x of 0. 2 pi small x of 0. So just we have to calculate what is x of t. In that we have to observe what is x of 0 value. Then if you multiply with 2 pi, we can get it. So let's say to get sampling square a omega as x of omega, what should be its a time domain expression? X of t has to be triangular wave between minus 2a, 0, 2a, and here 1 by 2a. So 2 pi into 1 by 2a, 2 get cancelled. Finally this is nothing but pi by a. This is nothing but pi by a. So if you observe carefully, so all of them are resulting into one thing, which is nothing but pi by a. So if you take sampling at, sampling a omega, sampling square at, sampling square a omega, so still the answer is pi by a. So if you integrate any of them, you are always going to get pi by a. Clear? Take it. Suppose if I consider for the similar thing, let's say integral minus infinity to infinity sinc at dt. Sinc at dt. This can be written as integral minus infinity to infinity sampling pi a t dt. So here it is going to be pi by a only, but in the place of a we are having pi a. So finally pi by pi a, pi get cancelled, finally 1 by a. So in the similar way, if we calculate integral minus infinity to infinity sinc a omega d omega 1 by a, again integral minus infinity to infinity sinc square let's say at dt, that is also 1 by a. Integral minus infinity to infinity sinc square a omega d omega, that is also 1 by a. So for all of them it is 1 by a, 1 by a. For all sampling functions it is pi by a. So take them. If the question is like this, integral minus infinity to infinity sampling square a omega e power minus j 2 omega d omega. Then what it is going to be? From the formula, suppose let's call it is a x of omega, x of omega e power minus j 2 omega. So that is going to give you 2 pi small x of minus 2. 2 pi small x of minus 2. So if we observe the formula for x of t, then you can get this one 1 by 2 pi something. So that 2 pi factor will comes here. What is x of t for this function? X of t. To get sampling square a omega, what is x of t? It has to be a triangular function. So better this is a 2 omega it is given. Sorry, it is 2 omega, not a omega, it is 2 omega. Then it is from minus 4, 0, 4, because 2 indicates width by 4. Width is nothing but 8, so it is existing from minus 4 to plus 4. And it must have area is equal to 1, so it is nothing but 1 by 4. 1 by 4. Now I want the value of x of t at t is equal to minus 2. So you tell me, at minus 2, what is its value? At minus 2, its value is equal to 1 by 8. 1 by 8. So if I substitute that 2 pi into 1 by 8, so this is nothing but pi by 4. Pi by 4. That is the answer. Let's see an example. X of t is equal to 1, 0. Its value is equal to 1 for mod t less than 1. Its value is equal to 0 for mod t greater than 1. Mod t greater than 1. Then if x of t, the two angular frequencies where x of omega is 0 are options pi 2 pi, option B pi by 2 3 pi by 2, option C 0 comma pi, option D 2 pi comma 5 pi by 2. So first you have to understand what is x of t given. X of t value is equal to 1 when mod t less than 1. That means between minus 1 and plus 1 its value is equal to 1. After that its value is equal to 0. That is what the meaning of it. Between minus 1 and plus 1 its value is equal to 1. So for this function, what is x of omega? X of omega is equal to, we know that it is area 2 into 1 2, sampling width by 2 1 omega. So finally I can write this one as 2 sine omega by omega. So for what values of frequencies this x of omega will become 0? So don't take omega is equal to 0. Why? If you take omega is equal to 0, its value is not equal to 0, its value is equal to 2. Its value is equal to 2. So from this I can say 0 is eliminated. So the remaining frequencies are pi, 2 pi, 3 pi, like that. So which option is going to be correct? So there is nothing but A. A. So if I draw this function, it will look like this actually. So at 0 its value is equal to 2, at pi 2 pi, like that. So for these frequencies it is going to be 0. So pi and 2 pi. Clear? Take it. Question number 9. Fourier transform of a signal h of t is h of omega, which is equal to 2 cos omega sine 2 omega divided by omega. Then the value of small h of 0 is dash. Options: 1 by 4, 1 by 2, 1. Okay, let's see how we can solve this one. Let's see. First, they have given h of omega. Write h of omega. Which is 2 cos omega into sine 2 omega by omega. So I can write this one as 2 cos omega into sine 2 omega by omega. So I haven't done anything, just I have written in that manner. Now you tell me. From Euler expansion, I can write cos omega as e power j omega plus e power minus j omega by 2. And 2 to get cancelled, finally this is nothing but e power j omega plus e power minus j omega multiplied with sine 2 omega by omega. So that can be written as 2 sampling omega, because sine 2 omega by omega. So here the omega factor is 2. Here the factor for the quotient for omega is equal to 1. So finally this is what we are doing. So let's call this 2 sampling omega as capital X of omega. Let's call this as capital X of omega. Now we can write this one as h of omega as x of omega e power j omega plus x of omega e power minus j omega. So this is what h of omega. This is what h of omega is given. Now if I try to find out h of t, so if I take inverse Fourier transform, then h of t. Let's say x of omega is having x of t, then what is the inverse Fourier transform of x of omega e power j omega? So which is nothing but small x of t plus 1. For this one, small x of t minus 1. So this is what the inverse Fourier transform. So in this one, they want to calculate at t is equal to 0. At t is equal to 0, h of 0 is equal to x of 1 plus x of minus 1. So they want to calculate h of 0. So if I know x of 1 value, x of minus 1 value, that's more than enough. So you tell me. So here the x of omega is nothing but 2 sampling omega. 2 sampling omega. To get this one, what is the inverse Fourier transform? That is x of t. So I know to get a sampling function, x of t has to be rectangular function. Zero, and it is existing between -1 and +1. and here the area has to be 1. So to get the area is equal to 1, sorry, area is equal to 2, area is equal to 2. So width is nothing but 2, height has to be 1, so that total area is equal to 2. So this is what x of t. So for this x of t function, what is x of 1 value, which is nothing but 1. What is x of minus 1 value, that is also 1. So I hope wait a second, somewhere something is wrong. Okay, so we have done a little mistake here. So this is not sampling omega, this is going to be sampling 2 omega, sorry. So sampling 2 omega, that's a mistake we have done. So if it is sampling 2 omega, this is going to be minus 2 and plus 2. Minus 2 and plus 2. Then what should be the height so that area will become 2? So that is going to be, this is nothing but 4. So what should be this height so that it is going to be 2? 4 means we have to say it is 1 by 2. 1 by 2. Now at t is equal to minus 1 and t is equal to plus 1. For both the t values, its value is equal to 1 by 2 only at minus 1 and plus 1. So finally I can say h of 0 is equal to 1 by 2 plus 1 by 2, which is 1, which is 1. I hope you understood. Take it. So I am sorry, here I have done mistake here. Sin 2 omega by omega is nothing but 2 sampling 2 omega. Okay. Let's take next question. Question number 10. Integral minus infinity to infinity 12 cos 2 pi sin 4 pi t by 4 pi t dt. What is the integral value is equal to? So nothing as mentioned. So they said what is the integral value? So many people think that it is a mathematics question, but it is not. It is a signals and system question. So let's see how to solve this question. So let's say this is equal to integral minus infinity to infinity cos 2 pi t can be written like e power j 2 pi t plus e power minus j 2 pi t. So divided by 2, 12 is 6 times. So finally we are left with 6 sampling 4 pi t. 6 sampling 4 pi t. So that's what we are going to get dt. Let's call it is x of t. Let's call it is x of t. Then we can divide this integral into two parts. One is integral minus infinity to infinity x of t e power j 2 pi t dt plus integral minus infinity to infinity x of t e power minus j 2 pi t dt. So if I say, so from the central ordinate property x of t e power j 2 pi t, so if you observe the integration, it is going to give you capital X of minus 2 pi plus this is going to give you capital X of 2 pi, capital X of 2 pi. So by observing this integral, so if I say this is x of omega, then here it is going to be x of minus 2 omega, sorry, minus 2 pi, and here it is x of 2 pi. So this is what we are going to get. Now we have to calculate what is x of omega. So in that we have to see what is x of omega value at minus 2 pi and plus 2 pi. So for that, first let's see 6 sampling 4 pi t. For this one, let's call it is x of t. Then what is x of omega? It is a rectangular pulse. Here 4 pi minus 4 pi. Then what is the value here? This is a pi by a into 6, 6 into pi by, so this is nothing but pi by a 4 pi, 4 pi. So 3 by 2, 3 by 2. Now I want the value at minus 2 pi and plus 2 pi, minus 2 pi and plus 2 pi. At both the values we are having 3 by 2, 3 by 2. So finally this is going to be 3 by 2 plus 3 by 2, which is nothing but 3, which is nothing but 3. Clear? Take it. If I ask, what is the inverse Fourier transform of u of omega? U of omega. So for this we have to calculate what is inverse Fourier transform, but it is not u of t. So let's say apply for duality. Let's say dual u of t. For u of t, what we got is nothing but 1 by j omega plus pi delta omega, pi delta omega. If I take the duality here, then this is going to be 1 by jt plus pi delta t. If I replace omega with t, then for this function we have to multiply with 2 pi, u of minus omega, u of minus omega. Now bring this 2 pi here, then this is going to be 1 by 2 pi into 1 by jt plus pi delta t, pi delta t. So here u of minus omega. So for u of minus omega, this is what the inverse Fourier transform, but we require inverse Fourier transform for u of omega. That means this minus omega has to be replaced with omega. So that means omega has to be replaced with minus omega. So to replace omega with minus omega in the time domain also we have to replace t with minus t. That is nothing but time reversal property. So from the time reversal property, so if I say 1 by 2 pi minus 1 by jt minus 1 by jt plus pi delta t, because impulse is a even function, so if I take minus t or plus t, it won't make any difference. For this it is u of omega. So this is the inverse Fourier transform for u of omega. Okay, take it. Okay. Next, find Fourier transform for one by pi t, 1 by pi t. So what is the Fourier transform for 1 by pi t? So it is looks like a unbounded signal. So for unbounded signals, Fourier transform does not exist. But in the beginning, I told you there are two exceptions. Even though they are unbounded, still we are having the Fourier transform. So this is one of that. So yes, even though it is unbounded, still it is having the Fourier transform. Now to get this one, so we will have to think in the duality property. That means 1 by pi omega. So which is not we are having. So let's say we know signum t. For signum t, we are having 2 by j omega. 2 by j omega, but I require 1 by pi t. So to get that one, we have to multiply with j by 2 pi signum t. If I multiply with j by 2 pi, j get cancelled, 2 get cancelled, 1 by pi omega. 1 by pi omega. For this one, if I apply duality property, that is going to be 1 by pi t. For 1 by pi t, what it is going to be? So again, we have to multiply with 2 pi, j by 2 pi, signum minus omega. Signum minus omega. So this can be written as minus j signum omega. How, sir? Because signum is an odd function, so I can write signum minus omega as minus signum omega. So finally, this is nothing but minus j signum omega. Minus j signum omega. So this is what the Fourier transform for 1 by pi t. Actually, this is nothing but Hilbert transform. This is not nothing but Hilbert transform. Suppose if a system h of t is equal to 1 by pi t, then that system is called as Hilbert transform. It is not a new transform, it is a system name, Hilbert transform. What the system will do? Suppose let's say h of t is equal to 1 by pi t. What is h of omega? Which is minus j signum omega. Minus j signum omega. What is this minus j signum omega? Which is having two values, minus j and plus j. If signum omega value, if it is greater than 0, then this is going to be minus j. If omega value less than 0, this is going to be plus j. So this is for omega greater than 0, omega less than 0. If I ask for this one, what is mod h of omega? That is magnitude spectrum. That is nothing but 1, because for minus j it is magnitude is 1, plus j is also magnitude 1. So it is always equal to 1. Then what is angle spectrum h of omega? So this can be minus pi by 2 or plus pi by 2 for omega greater than 0, for omega less than 0. If I draw these functions, let's say magnitude spectrum, so it is going to be a constant value which is equal to 1, which is equal to 1. Next, if I draw phase spectrum, so whose value is equal to plus pi by 2 minus pi by 2. So this is what it is. So in short, what is the Hilbert transform will do? It is not going to change the magnitude of the given signal, but it is going to introduce minus pi by 2 shift in the signal. So I am just writing those words. Hilbert transform does not change the magnitude of the input signal, but it changes the phase by minus pi by 2. Minus pi by 2. That is what the Hilbert transform. So in communication, this Hilbert transform having application in the generation of SSB. So single side binary signals can be generated by using the Hilbert transform. Okay, take it.